Hello everyone. So let's get started with today's class. Today the subject we are going to cover is computer networks. Let me check if the class is visible to you all or not. Okay, so in today's class we are going to revise complete CN, computer networks. Okay, and see, this comes for 8 to 11 marks. So in 2024 it came for 12 marks. In 2022 it came for 8 marks. In 2021 it came for 11 marks. Okay, so that is why, and these are the subjects, so 8 to 10 marks you can consider from this subject. And if you prepare this subject very good, then for sure you will be under top 100. Okay, you will be under top 100. So these some are the subjects which are tough and rank deciding, because always the questions come majorly with 2 marks. Okay, so that is what we are going to revise today. So till yesterday we have taken subjects which was easy to understand. Okay, and will also cover highest marks for you all, and these are the tough subject and it will also cover the highest mark. So now let's discuss this quickly. So computer networks, classful, addressing. So in classful addressing we have class A, which is of 10. The bit fix for class 0 is just 0. Class B is 10. Class C is 110. Class D is 1110, and class E is 1111. Okay, and this is called as the fixed bit. These are the fixed bits in computer networks. Okay, now let's discuss this with a diagram. Let's say this is the diagram. All right. This is the diagram we have, and now this is divided into one part. Okay, the part is like this. Okay, and again this is divided like this. The weight. Okay, and this part is divided as okay. So yes, we are back. Now this is how it's divided. Let me check that it's all visible properly or not. Yes. Now this part is divided again like this. Okay, so this is like a cake we are dividing. Yes. Now each part will have what? So this is A, this is B, this is C, and again this is divided. Okay, it is more divided again like this. Yes, so this is C, this is D, and this is E. All right, so And we have here, this is 2 to the power 31. Okay, this is 2 to the power 30. This is 2 to the power 29. This is 2 to the power 28. And this is 2 to the power 28. And the percentage it covers is, so, and the total IP address we have is 2 to the power 32. And this is how they are divided. So this will cover to 25%. This will cover to 12.5%. This will cover to 6.25%. And this will also cover to 6.25%. And this will covers up till 50%. Okay. So this you have to understand and revise. This make sure that you are doing this properly. Okay. Now let's see a table, okay, where we will be writing how much network ID, how much host ID, how much host per network, okay, and all of this thing, and the range also. So the class is there. Class is there. Network ID is there. Host ID is there. Okay. Host per network is there. Host per network is there. Okay. After that, range. Now understand. So this is A. This is B, this is C, this is D, this is E. Okay. So, and network ID here for A is 2 to the power 7 minus 2. Although network ID is 8, but 0 is reserved, so 2 to the power 7. And the first one with all zeros and all ones, they are specially kept for special purpose, so we don't include them. That is why minus 2. Okay. After that, this is 2 to the power 14. Then C is 2 to the power 21. Then there is no network ID assigned for D and E. Alright. After that, this host is assigned 24 bits. After that, this is assigned 16 bits. This C is assigned 8 bits. Again, for D and E, no bits are assigned. So how many hosts per network? So 2 to the power 24 minus 2, 2 to the power 16 minus 2, 2 to the power 8 minus 2, and as we don't have any network ID and host ID, so here host per network will not be there. Now it's time to see for the range. Okay. So range is, so for class A the range is 1 to, so the range is from 1 to 126. Second is 128 to 191. Then after that 192 to 223, 224 to 239, and 240 to 225. Directly you have to remember this. And you have to remember one thing, that 0.0.0.0, this is default router, okay, or DHCP client. Okay, this is known as default router or DHCP client. And 27.x.x.x. What is this x? Any number you can put here. Okay, any number you can put here. So, but the starting should be of 127. So this is called as self connectivity. So see, if you want to send a message to someone, but it is not getting delivered, you are not getting the response. So definitely you will check that your network is good or not. So you will send the message to yourself. So in the destination, you are going to put 127.x.h, some number for just checking. Okay, this is also called as loop back testing. This is also called as loop back testing, and it is also called as inter-process communication. Inter-process communication. And one thing you should note that 127.x.x.x, this is used as only destination IP address. It is used as destination IP address, not source IP address. Okay, only destination IP address it is used for. Okay, now I hope this much is clear. Now ARP request. So ARP request is broadcasting request. After that ARP reply. So this is unicasting. ARP reply is unicasting. Broadcasting means to all the IPs our message is delivered. Okay, to all the IPs our message is delivered. Unicasting means one-to-one messaging. Okay, unicasting means one-to-one messaging. After that, let's see now type of communication from this. Types of communication. So the very first type of communication is, first is unicast. Okay, and here it is from 1 to 1. Unicast means 1 to 1. Second is broadcast. Okay, broadcast means 1 to all. So let's say if I have to deliver some message in the class, I am broadcasting the message to all. Okay, all the possible people, 1 to all. So this is broadcasting going on, right? Yes. And what is multicast? So multicast means 1 to many. 1 to many, but not all. Okay, many, as much as we can. So this is multicast, right? Now let's see what is direct broadcast addressing. So direct broadcast addressing means transmitting data from one to all computer. Okay, so this is called as DBA, which is direct broadcasting. Okay, direct broadcasting. So this is what is direct broadcasting. Here in host ID part, all are ones. When you find in the host ID part all are ones, then it is DBA. Okay, what is LBA? Limited broadcast addressing. So limited broadcast addressing is just 255.255.255.255 1 2 3 4. Okay, and this is same for all the class, same for all, whether it is class A, whether it is class B, whether it is class C. Okay, so it is same for all, it is not at all different. Okay, after that let's now revise. So this is, I hope this is clear. Now let's move on to subnetting. But why from this we move to subnetting? Because what was the drawback here? All the portions were divided in such a way that, let's say this is 2 to the power 30, but I just want 2 to the power 25 IP addresses. So the rest of the IP addresses will go west. Okay, and I cannot utilize that. So because of that, subnetting happened. And in subnetting, this is just a chart. Whatever IPs I want, I will just take the portion, remaining I don't care. So this is called as subnetting. Okay, so that is why from here we move to subnetting. So let's move. Yes, and from so before moving to subnetting, let me clear that what is valid network ID, host ID. So network ID, host ID chart we will make, which is valid, which is not. So network ID is valid when? So valid network ID is there, and in host ID all zeros are there. So when valid network ID is there and in host ID all zeros are there, then this is network ID. This is network ID of entire network. Okay, and again here valid network ID is there and all the ones are there, then this is DBA, which is direct broadcast address. And here in net ID also one is there. Okay, and host ID also ones are there, then this is nothing but LBA, limited broadcast addressing. So this you have, this table you should remember very carefully. Now let's go for subnetting. I hope till now everything is clear. So subnetting is nothing but borrowing bits from host ID. Okay, Subnetting is nothing but borrowing bits from, not host from, bits from host ID. Okay, so n bits borrow, that means 2 to the power n subnets possible. 2 to the power n subnet possible. So can you all tell me quickly that if I borrow 2 bits, how many subnet possible? 4 subnets are possible. Okay, and for each subnet, 2 to the power, okay, so 2 to the power n minus 2 host per subnet possible. Why minus 2? Because here also we have to just cancel all the 0 zeros part and all the 1 1 part. That we don't have to consider. So that is why minus 2. Total combinations will be 2 to the power n minus 2 we have to do. And there here n represents the borrowed bits from the host ID. Okay, so this is called as subnetting. Alright everyone. Now let's go for classless addressing. So let's see a structure for classless addressing. Classless addressing. So classless addressing is nothing but a dot b dot c dot d by n, and this n is nothing but network ID subnet mask. Okay, network ID subnet mask. This is what supernetting. So supernetting is nothing but combining 2 or more networks. Combining 2 or more networks. Combining 2 or more networks. Now let's see rules for supernetting. Okay, we will see rules for supernetting. Rules for or rules of supernetting. Rules of supernetting. So the very first rule is network ID must be contiguous. Network ID must be contiguous. Second is size of network must be same. Size of network must be same, and number of networks must be present, must be power of 2. Third is first network ID must be divisible by the total size of the supernet. Total size of the supernet. Okay. Now just note one point, that number of corrupted bits is equals to data rate into noise duration. Okay, now let's discuss Hamming distance. Hamming distance. So distance between two binary strings of same size, okay, is the number of difference between corresponding bits. So this is called as Hamming distance. Okay, now to detect d bit error, minimum Hamming distance required is d plus 1. Okay, and to correct d bit error, minimum okay, Hamming distance required is 2 into d plus 1. Alright everyone, so note this. After that we will see CRC and polynomial notations in CRC, and after that we will write some important points regarding this. So I guess till now there is no doubt, okay, in this. So note this everyone, after that we will see CRC. Okay, now let's see CRC. CRC, okay. The very first point is length of data word is equals to n, okay. Second is length of divisor is k. Third is append k minus 1 zeros to original message. And fourth is perform modulo 2 division. Okay. Fifth is reminders of division is equals to CRC. Sixth is code word is equals to n plus k minus 1. Seventh is code word, okay, code word is equals to data word with appended k minus 1 zeros plus CRC. Okay, so this will be the case. Now let's see some notations. polynomial notation in CRC. Polynomial notation in CRC. So data word, which is d of x, code word, which is c of x, generator, which is g of x. After that, syndrome, which is s of x, error, this is e of x. Okay, so the first is we have to determine degree of r of g of x, which is the highest power. Okay, which is the highest power. Second is we have to determine x of r d of x. Okay, third is we have to get the remainder by dividing x of r d of x by g of x. Okay, fourth is code word is equals to x of r d of x plus remainder, like this. Alright, so a generator that contains a factor of x plus 1 can detect all odd numbered errors. Okay, and if the generator has more than one term and coefficient is x to the power 0, which is 1, then all single bit errors can be detected. Okay, and if a generator cannot divide x to the power t plus 1, where t is between 0 to n minus 1, then all isolated double errors can be detected. Okay, and what is a good polynomial generator? How should we decide that? So it should at least have two terms. Okay, second is the coefficient of x to the power 0 should be 1, and it should divide x plus t plus 1, and where t bit is starting from 2 to n minus 1, and it should have the factor x plus 1. Okay, so I hope the points are absolutely clear, and if you want to note the points, so you can pause the video and can note one point. But as this is the revision class, so I definitely could have just thought that you all know this point. Okay, now let's see, according to Hamming code, what is reductant bit, what is reductant bit position. Okay, according to Hamming code, reductant bits is equals to m plus r plus 1. It is smaller than 2 to the power r, where r is lower limitation. Okay, reductant bit position is equals to 2 to the power I, where I is smaller than equals to 0. Okay, and note this table, very important table. Okay, data and bandwidth. Kilo, kilo, mega, giga. Okay, so it is like 2 to the power 10, 2 to the power 20, 2 to the power 30, and this is like 10 to the power 3, 10 to the power 6, 10 to the power 9. You should know this table. For solving problem, you should know this table. Okay, I hope there is no doubt. So note this everyone quickly. Okay, now let's see the next one. So next we are going to see transmission delays formula. Okay, transmission delay, progression delay, that we are going to see one by one. Transmission delay, so which is TD. Okay, that is how it's represented, which is L by B, and this L by B is, this L is frame, okay, or packet size, we can say frame or packet size, and this B is definitely bandwidth. Okay, now progression delay. So propagation delay, this is PD, and this is distance by velocity. Distance by velocity. So total time or round trip time, T RTT, which is TD, which is frame, plus 2 PD plus QD plus, okay, PD plus TD. So this is of acknowledgement. Okay, and efficiency of stop and wait, which is TD, which is frame, by total time, and throughput is equals to efficiency into bandwidth. Okay, and stop and wait uses independent acknowledgement. It uses independent acknowledgement. Understanding, everyone? Any doubt till now? I hope there is no doubt. Okay, now let's see in stop and wait ARQ. Stop and wait ARQ. So some very important thing we are going to note. Efficiency when PD and TD. Okay, so I am going to copy this same again, and this is I am going to copy for 4 times. Yes, because we needed it for the 4 times. Some analysis we are going to do for this. So this one again, yeah, one last time. So see, efficiency is down when propagation delay is up and transmission delay will be down. Efficiency is up, propagation delay is there, okay, and this will be propagation delay is down, transmission delay will be up. Okay, and here when distance and bandwidth. Okay, so first is distance and bandwidth. Here is packet size and distance. Okay, so efficiency is low when distance is up, so bandwidth is also up. Okay, after that efficiency is up So packet size is also there and distance is low, like this. So now let's discuss sliding window. Okay. Sliding window. Sliding window. So the very first point is maximum window size. Max window size. What is the maximum window size? So which is 1 plus 2a packet. Okay. After that, second is minimum sequence number, which is 1 plus 2a, and this a is nothing but PD by TD. Okay. After that, third is minimum number of bit required for sequence number, which is log base 2 1 plus 2a. Alright. Now let's see go back n. Let's see the formulas for go back n now. Go back n, where n is greater than 1. Okay. So sender window size is n. Okay. Receiver window size is 1. Okay. And it uses cumulative acknowledgement. Okay. So sender window plus receiver window is available sequence number is smaller than equals to available sequence number. After that, sender window plus 1 is equals to acknowledgement. Okay. And sender window, this is minus 1. And now if we talk about efficiency, so efficiency is nothing but n into TD, which is frame, by total time. Okay. And here sequence number, which is k bit. So sender window is 2 to the power k minus 1 and receiver window is 1. Okay. After that, let's see selective repeat or selective reject. Okay. Selective repeat or selective reject. Very first is window sender size is equals to window receiver size. Second is sequence number is equals to k bits, where sender window is k 2 to the power k minus 1. Receiver window is also 2 to the power k minus 1. Efficiency is sender window into frame size by total time. Alright. Now let's see a table where we will see efficiency, we will see sequence number, okay, and sequence where it is k bit. Okay, and this for all we are going to see. So first is stop and wait. After that, go back n. After that, selective repeat. So here first we are going to cover efficiency. After that, buffer. After that, sequence number, and sequence number is k bit. So n is equals to 2d total time. Buffer is 1 plus 1. Sequence number is 2, 0 and 1. And this is not nothing. After that, here n is equals to td into n by total time, where it is n plus 1. This is n plus 1, which is from 0 to n. And receiver window, sender window, we have 2k minus 1 and here 1. Here is n equals to td into sender window by total time, which is n plus n, which is 2n 0 to 0 to 2n minus 1. Sender window, receiver window, so 2k minus 1, 2k minus 1, like this. Alright. Now after that, we will see the IPv4 header. Okay, IPv4 header. So this is IPv4 header. All right. Then okay. Okay, it's like this. Okay, so it's like this, it is divided. After that, it's divided in this section, again like this. Okay, like this. This is divided like this and this way. So it's divided like this, like this. Yeah, and this is of 32-bit, this is of 32-bit, this is of 32-bit, this is of 32-bit, this is of 32-bit. Okay, and this is variable, so 40 bytes, and this is of total 20 bytes. Okay, so actually this one is optional, 0 to 40 bytes one. Okay, this is destination IP address, which is of 32 bits. This is source IP address, which is of 32 bits. Okay, this is TTL, which is 8. This is protocol, which is 8. This is header checksum. So this is for 16 bits. Okay, so identification number, which is of 16 bit. After that, flags are there, 3 bit. Fragment offset is there, which is of 30. After that, total length 16. Services are there, 8. HL is there, 4. VR is there, 4. Okay, so IP is a packet stream protocol. TCP is a byte stream protocol. Now let's see the order. Okay, and yes, here the point to be noted is minimum header size is equals to 20 bytes and max header size is equals to 60 bytes, and scaling factor is equals to 4. Okay, so order of elimination of datagram from buffer is ICMP, IGMP, UDP, TCP. Okay, all right. Now which cannot change here in table? Destination IP address cannot change, source IP address cannot change, protocol cannot change, DF cannot change, identification number services cannot change, VER cannot change, and which may be changed, which is total length, NF, MF, okay, which is offset, fragment offset, header length, optional can change. After that, what will definitely change? So TTL will change, header checksum will change. And what is MTU? MTU is maximum amount of data that can be stored in any data link layer, and fragmentation is done by intermediate device, which is called as router. So here fragment okay, okay everyone. After that, same we will have TCP header as well. So do look into TCP header. Okay, source port is of 16, destination port is of 16. Again, sequence number is 32, acknowledgement is 32, header length is 4. Okay, after that 6, after that some bits are there which is of 111, window size is 10, checksum is 16. Okay, urgent pointer is 16. After that, optional is again 2 to 14, and every single row is of 4 byte. Okay, so for TCP header, minimum header size is 20 bits, maximum header size is 60 bits. So 0 to 123, this is well known port number. 0 to 49,151, this is for reserved registration or registered port number. Okay. And after that 49,512,265,535, this is of dynamic port number. This is of dynamic port number. And timer TCP, this is of TD plus 2 into PD. Okay. So basic algorithm. After that, all this you should know. And what is TCP checksum, which is TCP data plus TCP header plus IP pseudo header. Alright. Now token bucket you should know. So token bucket, which is max number of packets, is equals to C plus RT. Here C is capacity of token bucket, R is rate of token entering, T is maximum number of packet enter into network during the interval T. Okay. Second is max average rate of token bucket, which is C plus RT by T, and here T is equals to C M minus R. Okay. And do look into UDP header as well and know the difference between TCP and UDP. So TCP is dynamic header, UDP is fixed header. TCP error and flow control is there. Here in UDP no error and flow control is there. After that, connection oriented is TCP, connection less is UDP. TCP is reliable, UDP is not reliable. TCP high overhead, UDP low overhead. Okay. TCP ordered maintain, UDP no order. After that, examples of TCP are protocol, which is HTTP, FTP, SMTP. And here UDP protocols are DNS, SM, SNMP. Right? Any doubt till now? No doubts? Okay. So contiguous control algorithm is TCP. So slow start phase, exponential increase. Contiguous avoidance is additional increase. After that, contiguous detection is multiplicative decrease. And WAP is, the formula is total sequence number by bandwidth, and bandwidth is okay, and minimum sequence to avoid WAP is LT into B. So do note this, everyone. So total length in UDP to the power 16 minus 1, okay, and practically data size at transport layer at UDP is, okay. So when the destination port is well known, port number, data making client, which is server, okay. And when source port is well known, port number, data moving from server to client. So let me write this. When destination port is well known port number, then data moving from client to server, okay. When source port is well known port number, then data is moving from server to client. All right. Now the next topic is pure Aloha, slotted Aloha, SMA, okay, Ethernet, and all of this. So much is still left to discuss in CN. I don't think so that today the whole CN will get revised. Tomorrow's half class we will require for this, because still there is so much to revise. So in today's class, till now, anyone having any doubt, just tell me. Any single concept, if you are not understanding, any single question, so you can all comment, okay? Because I do read the comments and I reply also. So if you are facing any doubt in any of the topic, you can just ask me, I will answer, okay? So every day I am just taking 1 hour of class where I am discussing all the revision part which should be revised for every single subject. So I have covered with total algo DSA programming, TOC I have covered, CD I have covered, okay? After that DBMS digital I have covered. So all these subjects are really, they have really nice weightage, and trust me, they are easy to score. And from today I am taking hard subjects. So first I have picked CN because it is asked for 10 to 12 marks, okay, in that range. So definitely you should not miss. So soon I will end the class. Do let me know if you have any queries, any doubt. Do check the channel. There are live videos available, okay. And the remaining part, what we will do, we will cover tomorrow. Because today we cannot just cover the complete CN. Okay, so from pure Aloha, we will start from tomorrow. And today if you have any doubt, you can just comment and you can ask me. Alright, so thank you so much everyone for attending today's session. See you all